This is Jack Jackson. In this video, we're going to be showing you how to use Texas Instruments calculator technology on a TI-84 and a TI-nspire for computing one sample z-tests. You're going to like this. So just as the Texas Instruments graphing calculators have a program included to compute z-intervals, they also have a similar program for performing z-tests, along with several other standardized testing and hypothesis tests and confidence intervals. All of these built-in confidence intervals and hypothesis tests work in a very similar way on these calculators. On the TI-84, to access the tests and intervals, we begin by pressing Stat and the left arrow to get tests. You'll get a screen like this. You could either hit right arrow twice or left arrow once to get to test, and you choose the first one by either pressing 1 or actually just press enter here. To do the same thing for the TI-nspire, you go to Menu, you press Statistics, Stat Test, and then Z-Test. Notice that the TI-83 works the same as the TI-84, but it may not have all of the tests that the TI-84 has, but it definitely has the z-test. The TI-82, which is an older calculator, does not have all of these shortcut apps, so I do not suggest using it for statistics. Okay, so let's see how to put this into work in a real-world problem. A cheetah is the world's fastest land animal. An article reported that the mean top running speed of all adult cheetahs is 60 miles per hour with standard deviation of 3.2 miles per hour. So we say, I wonder about that. I wonder if they're telling the truth. So we go out and we measure some cheetahs ourselves. And we follow the sample, follow these cheetahs, and get some top running speeds for them. And here we get a bunch of data, 57.3 miles per hour, 57.5 miles per hour, and so forth. So what can we do? Well, the first thing we do is we type all this data in a list. So we go to Stat, Edit, go to List 1, put your cursor on List 1, hit Clear and Enter. Then move down in the list and start typing in the data one at a time. 57.3, enter. 57.5, enter, and so forth. Keep doing this till you get it all done. There's no getting around typing in data somewhere. If somebody has to do that, or we can't work with the data. Now, the next thing we do is to go to a z-test. Okay, remember I just told you how to do that. It's Stat, left arrow to test, choose the first one, z-test. And then in this case, we have our data in a list. So we have our data in our list. Just like for the z-interval, we choose data. If we already have the mean figured out and the number of data of sample size figured out, we could use statistics for that instead. But in this case, we've got the raw data, so we click on Data here. Our mu naught is our null hypothesis, which is 60 miles an hour. Hey, these people did some research. We're going to assume they're telling the truth unless we have enough evidence to call them out on that. We're not going to call them a liar unless we got enough evidence to back ourselves up. Pretty strong evidence. So we type in what they say is 60, and they also tell us the standard deviation is 3.2, so we put that in there too. We tell it our data is in our list L1, which we can get by typing second one. And all the things I'm going to give you, frequency will always be 1. Now, the only way you'd put something different there is if you had a frequency table here with data values in L1 and frequencies in L2. Then you could put L2 here. But for us, we're always going to have 1 because our data is going to be in a single list. Just put the name of that list up here. Now we have a choice of our 3 possibilities. Two-tailed, left-tailed, or right-tailed for the not equal to, less than, or greater than, respectively. So the one on the right, greater than, that's right-tailed, less than, the middle, that's a left-tailed, and then not equal to is the beginning, that's a two-tailed. Okay, suppose we want to do a two-tailed test. Okay, we wanted to see if they're, here's the question. At the 5% significance level, is there enough evidence to conclude that the mean top speed for all cheetahs is different than 60 miles per hour? So the different than tells you it's a not equal to or two-tailed test. Now we have two choices. We can click on calculate and enter or draw and enter. I'll show you both. Let's say first if you click on draw, you'll get this right screen here and you see the shading with the p-value and the z-star test statistic. In this case is negative, so it's right here. And to be a vertical line right there at that z-star, to the left of it is a certain amount. We the same amount on the right. We double that, we're going to get 0.4961. That's the p-value. Most of the time, though, you really don't need the actual shading. So most of the time, I'm not going to do draw. I'm just going to go straight to calculate. So if we go to calculate, here's what it returns, this screen here. Notice it returns the alternative hypothesis that mu is not 60. It returns the test statistic, z-star or z is negative 0.68 something. It returns the p-value, 0.496, etc. The x-bar value, which is just the mean from that, so is given. So there's no need to run the one variable statistics. This basically does that for you. It returns the S value, our sample standard deviation for this point is not needed at all in our calculations. They could have just left that out. And then we did need the sample size, which is 34. But the most important part of this is what? Really just the p-value. So we pull that p-value of about 0.496, and we see that that is greater than alpha. Actually, it's way bigger than alpha. That's a very big p-value. And so there is not enough evidence, in fact, there's very little evidence at all, that there's any chance that this is really different than what they're saying of 60 miles per hour. So there's no evidence there. We fail to reject the null hypothesis. So we basically can do the same thing on a TI-nspire. So this is the same problem. Let me show you how to do that. First, establish that the conditions for a z-test are made. Open a spreadsheet page. Remember, in Nspire, you can have a calculator page and you have a different spreadsheet page. Get on a spreadsheet page and type in. I named this some suggestive name, in this case speed, up here at the very top one, and then put the data down here. Then I go back to the calculator screen, so get over to that, and I go to stat or go to menu, then press statistics, hypothesis test, and number 1 z-test. This next screen comes up here and it asks you whether you want to use data or statistics. So you click on that if you want to change the statistics. It says data, so I click OK, and I put in my data. I put in my information here. Mu naught is the hypothesized mean, which is 60. The sigma is the standard deviation of individuals, which is 3.2. Our list, where is it stored? Well, I gave it a name speed, so I can choose that from the options here. Press the drop-down menu, choose it from what's there. Frequency list is 1 again, just like the TI-84. And the alternative hypothesis, you do the drop-down here, you get a choice for a left-tailed, right-tailed, or two-tailed. We chose the two-tailed here. Then click OK, and the answer comes up in a matrix. We have the alternative hypothesis, the z-star test statistic, the p-value, the x-bar value. This is the standard deviation of the x's from the sample. We have n and sigma all given there in the answer. The main thing, of course, is the p-value, 0.496 once again. So once again, that's too big to reject the null hypothesis. We failed to reject the null hypothesis with that. Okay, here's another example. See if you can try this one with the calculator now that you've seen how to do it. Assume the mean resting heart rate of all adults are distributed normally with mean 72 beats per minute and standard deviation 11.2 beats per minute. A sample of 90 adults were tested while watching films designed to generate laughter. Heart rates during laughter were measured and found to have a sample mean of 74 beats per minute. Use a TI graphing calculator to perform a test of hypothesis to determine if there is evidence at the 5% significance level that laughing increases heart rate. See if you can do this one on your own. Press pause now. Well, now if you're back, hopefully you've tried this on your own. Here are the solutions. The top is the TI-84 screens. The bottom is the TI-nspire screens. We choose tests. Z-test from the TI-84, that's stat, right, left arrow once, and then choose number 1. Comes up with the second screen. We're going to choose stats this time. The mu naught is 72, sigma is 11.2, x bar is 74, n is 90, and this time we want a right-tailed test. Go to calculate. It gives us this right here. There's the alternative hypothesis, the Z-star test statistic, the p-value, the x-bar, and the n. And the main thing is the p-value is 0.045. We're comparing it to an alpha of 5%, so it's barely under. So there's evidence strong enough to conclude that the null hypothesis is false. Okay, so we reject the null hypothesis in favor of the alternative hypothesis. Similar thing from the TI-nspire. You can see the screens here. Choose menu, statistics, stat test, and number 1 Z-test. Choose stats here. Click OK. And then we choose mu naught is 72, sigma is 11.2, x bar is 74, n is 90. Right-tailed test, so choose greater than here. Click OK, and it returns everything here. Most importantly, the p-value there. In our next video, we're going to introduce a lab project that you can do by watching the videos. It's a lab project with dealing with dice. So in this case, you're going to watch the video, collect some data, and then do a hypothesis test. So the next video is going to kind of set that up, and the following video is going to show me actually rolling some dice that you can use to create your hypothesis test.